Next up, we have Sarav Arunachalam, who is the director of the Center for Environmental Modeling and Policy Development.
There you go. Thanks, Mike. And thank you all for the invitation to present here. So, when I got the invitation to present, we do a lot of different model development, model applications for different activities to support environmental policy making. Thought a bit about what I may want to present here, and then I said maybe, I'm not sure how many of you saw the news last week. There was a major proposal from the Biden administration, the EPA, looking at vehicular emissions and a proposed rulemaking to address vehicles to decarbonize the fleet. So I thought maybe that may be of interest here. But I took a slightly different angle based upon what that rule was all about and what science goes behind it. So that particular rule talks about carbon emissions, and we want to decarbonize the vehicular sector quite a bit. But when you decarbonize vehicular emissions, there's a substantial other aspect of that, which is cleaning up the air from the tailpipe exhaust from other pollutants, which goes on to form air pollution and then affect human health in the short term. So it's a substantial benefit that comes from decarbonizing vehicles, which improves public health from the air that you and I breathe. So I thought maybe do a case study demonstration of how science is used to make policy like that and look at some cost-benefit analysis of a similar rule. So this is looking at the distribution analysis of air quality health benefits of medium heavy-duty vehicular trucks in New York City, a specific large city with a very large transportation problem. And this is work being done collaboratively with a couple of different entities, specifically Environmental Defense Fund, a fairly large advocacy group in the US, and then 2 other schools of public health who assisted with the bulk of the health data that we used in the study. So what motivates this kind of a work? If you look at the US, about 1/5 of every American lives next to a major highway. When I say next to a major highway, it's within the first 100 meters or so. That's the number that we have. So quite a lot of people living right next to a highway. But if you look at some of the very large populated counties like Los Angeles or New York, you may have more than 2 out of every 4 people or 1 out of 2 people living next to a major highway. And then why is it important? Traffic emissions, if you look at the gradients of air pollution from traffic emissions, that's a plot which shows how air pollution from trucks or any vehicular emissions falls off when you go away. The point is not working. Anyway, okay, so the point is not working, but the point is if you look at the second graph here, the x-axis shows distance away from the road, y-axis shows the normalized, oh, maybe something is popping up right there, okay. Normalized to the edge of the road. What it shows is the pollution drops off very sharply next to a highway, so capturing this first couple of 100 meters in terms of what the gradient is of air pollution is very important, and that's where a lot of people live, as shown in the next left figure. So what we did was look a little more carefully and look at the emissions sector from vehicular emissions. So transportation is a fairly large component of vehicular emissions. We have 50% of total oxides of nitrogen, 6% of all organic compounds, primary PM, and so on. And these goes on to form various air pollutants that affect human health, specifically fine particulate matter, ozone, and nitrogen oxide, which have various health effects from premature deaths to respiratory illness, heart disease, and so on and so forth. But then from this sector, the heavy-duty vehicles pollute fairly disproportionately, fairly large amount of emissions, but then they're very small percent of the total fleet. 3% of the fleet having 40% of on-road mobile emissions. And these vehicular emissions, heavy-duty trucks, could contribute to overall very large portion of the mobile source NOx emissions. So you want to basically look at this particular sector and then what this means when you decarbonize this. Few different studies that came out in the media recently, mostly from the current administration, to look at addressing this through various proposed rules. These came, the top left came in the August of 2021. The one on the right came late last year to tighten rules on pollution from vans, buses, and trucks. And actually from our group, we looked at this proposal from the EPA and did some analysis that I'm going to present here and submitted as comments to the EPA, which was then finalized later in the December of 2022. And the one on the bottom left is the one that came out last week to look at accelerating the transition to electric vehicles in the overall US economy. All right, so the objective of the study is to quantify the distribution of air quality health benefits of medium heavy-duty trucks in New York and Atlanta. I'll focus just here on New York City. And then to look at the quantification of these differences across neighborhoods, census tracts, population subgroups, and so on by various population demographic subgroups. So if you look at the truck activity in New York City, it's fairly non-homogeneous, where you have quite a bit of trucks in different roads, and the colors show the number of trucks on a daily basis. That they go from between 100 to 5,000, the bottom, the lowest color, to more than 20,000 trucks per day in some areas of the city. But then if you look at the health incidence, children in communities of color and low wealth have fairly high rates of asthma. So this talks a little bit about environmental justice. That is quite a bit of attention in the news of late. So if you look at that's New York City, and the red counties, red portion of the domain on the top right is Bronx, where we saw that the asthma-rated ED visits, or emergency department visits of children, young children, were more than 5 times higher in high poverty New York City neighborhoods compared to low poverty neighborhoods. Okay, so you have a fairly large baseline incidence of asthma in these poor neighborhoods. So here are some numbers at the bottom from the New York City Health Department. So we want to look at how potential fleet electrification may benefit or not when we have differences in baseline health incidence and compared to truck activity. Okay, so what we did was looked at a baseline scenario where we project emission to the future for future year 2040, and then look at 2 specific electrification scenarios of this fleet. One is we assume that 100% of EV sales for trucks and buses will be there by 2030. And then scenario 2, 100% of on-road medium heavy-duty trucks by 2040. So that was sort of the 2 different scenarios. The second one is a lot more aggressive, which basically reduces the NOx emissions almost completely, and you only have a little bit of VOCs and fine particulate matter left. So these are 2 different scenarios we looked at and modeled them. And sorry about the right part, it's got cut off a little bit. Not sure if I can do anything, but I'll move on for now. So the modeling approach for this is basically an approach where we start with looking at the transportation options. You look at the travel activity, and then you get emissions factors to see how many emissions of different pollutants there from these trucks on a per kilometer or per mile basis. Then the last part, which you see beyond AQ, is the air quality modeling piece, which my group does a lot of. Then we take analysis and then use a tool called BenMapper. What that does is takes the unit change in concentrations and then applies that to estimate what is the unit change in perhaps health risk, both from morbid as well as mortal endpoints. And the last one is doing some equity analysis to look at how these benefits are changing across the city. So first result, looking at the baseline. So what this shows is New York City looking at 2 different pollutants, fine particles on the left and nitrogen dioxide on the right. And what it shows is our modeling framework, which basically was able to estimate air pollution in these in the city for these 2 pollutants at a very, very fairly small or granular fashion. And basically, if you look at the city, we divide the city into about 2,000 or so census tracts. That's the number of tracts we have in New York City. We're able to estimate air pollution in every tract, and that's the level of detail we have in the modeling. And what you see is the hotspots in terms of where we have high baseline levels of fine particles on the left and high baseline estimates of nitrogen dioxide. And if you look closely, actually, you can see some of the highways in New York City, where we show that based upon the highway or truck activity, you do have fairly large amount of air pollution. Then we moved on to look at the scenario, second scenario that I mentioned, to see what will happen if you move to a 2040-based electrification of the truck fleet. And this is a difference plot showing the differences in fine particles on the left and of NO2 on the right, to show how much PM or NO2 is reduced. And you can see that actually the roads pop up much better on these plots because you're basically removing the emissions of these trucks on these roads. And what we saw was across the city, based upon this policy option, there's fairly wide variation in the distribution of air pollution benefits from these trucks across the census tracts. But what we also saw was these benefits vary quite a bit. In the top 20% of benefits, they have up to 10 to 13 times higher air quality benefits from this particular policy from the EPA, which shows this cost-benefit analysis that there's a 10 times benefits as opposed to cost. This is the kind of science that goes behind how those rules are made from the federal or state government. But that I'll summarize with some key points. We have this very comprehensive but detailed framework to look at census tract level of air pollution. And what we were able to do from this particular approach was these have a fairly significant improvement in the ability to model disparities in transportation-related air quality benefits. So when we presented comments to the EPA did fairly coarse resolution modeling across the country. What we said was you need to look at this much more finer resolution, finer granularity, and showed how the benefits vary across different subpopulations based on population demographics. And the medium heavy-duty vehicle electrification will have significant air pollution in New York City. We did this for Atlanta too, but I didn't go through Atlanta results in the interest of time. but overall, 20% of the tracks in the city contribute to 20 to 80% of total NO2 and a fairly small portion of total PM. So I just want to walk through a specific example, which maybe some of us may be able to relate to from the news media blast that happened last week from the EPA.